Hey guys, today we're going to continue reviewing stuff about logarithms, and we're going to start solving log equations. So you're going to ask yourself, what methods can you use to solve an equation using logs? So we're going to start with my first method, which is going to be when I try to condense down both sides until I have one logarithm, so then hopefully if they have the same base, I can set the arguments equal to each other. So again, the condense, that's the steps that we were doing the other day. And we're going to go ahead and try to make this right side into one log. So the first thing I know is if there's a number in front of my log, I can put that up in the exponent, and that would just be 4 squared, or 16. So I would have log base 3 of x equals to log base 3 of 16 minus log base 3 of 2. Now if you notice here, since I have the same base on both of these logs, I am allowed to then combine them. And since it is a minus in the outside, that means that we actually have a quotient on the inside. So I'd have 16 divided by 2, which is 8. Now if you notice here, I have the same log base on this side as I do this side, which must mean that my arguments have to be equal to each other. So this is pretty straightforward. X must be equal to 8. So again, this one right here, we try to condense down as much as we can on each side until we have two separate logs with hopefully the same bases, and then I can set their arguments equal to each other and just use some algebra. The second method that we can use is to rewrite in exponential form. So if you're faced with a log equation that says log of something equals something else, we could go ahead and rewrite this using that log thing that we know. So we know that log base b of a equals to x can translate either direction into b of x equals a. Okay, where your base is the same, this is your exponent, this is your argument. So if I go ahead and take this guy, I'm going to rewrite it using my log rule, and I'm going to know that this is actually 3 to the second power is equal to the argument, or 2x minus 3. This becomes an even simpler problem to solve because all this is a regular algebra equation. I have 9 equals 2x minus 3. Add 3 to both sides, divide both sides by 2, and I would get that my answer was 6. The next type of method we could use to solve is basically a combination of method 1 and 2. We're going to try to condense down my logs as much as I can on either side of the equation, and then I'm going to rewrite it in a different way. So this right here, I know if I have a plus in between my two logs, then that is actually a multiplication on the inside. So if I have this, I'm going to multiply. I'm going to use a lot of parentheses here. Okay, and then I can go ahead and rewrite this using the log rule that we just talked about. And remember, if there is no base here, then that must be a base 10. So I'm going to take 10 to the first power is equal to everything that was in that argument. And you're going to notice here, if you go ahead and you FOIL this out or use your box, whichever one you wanted, this would actually then become a quadratic equation. And we know if we have a quadratic equation, we're going to try to set it equal to 0, okay, and then factor or use the quadratic formula. So if I subtract 10 from both sides here, I'm going to get this guy. And this does actually factor nicely. We're looking for the factors of negative 12 that add up to positive 1. So my two factors would just be x minus 3 and x plus 4. Now I can set each of those factors equal to 0, so I would know that x could be 3 or x could be negative 4. Here's the part where we kind of have to pause and make a note and remember that because we're talking that logs are basically exponents, we need to remember that the argument of a log, the inside of a log, can never ever ever be negative. I'm just going to abbreviate. So the argument of a log can never be negative. So if I take both of these answers that I got and I plug them back into the original expression I had, 3 plus 2 is positive and 3 minus 1 is positive. So that's good. X equals 3 is an answer. However, if I plug in negative 4, that's going to get me a negative 2 here and a negative over there. So this can't be one of my answers. If you remember, this is called an extraneous solution, and it happens when the domain of your function is not all real numbers. So you just have to double check that when you plug your answers back into the original, you don't get any negative arguments. Okay? The last type of log equation that you might see is something that looks kind of like these two examples. And so the method that we're going to use is to try to rewrite using the same base or as a log, or possibly we can take the log of both sides. And I know that's a lot of different things that could happen here, but they're all kind of the same process. So originally when we were faced with a problem like this guy, we would say, well, how could I rewrite these in the same terms of the same base so I could set the exponent equal? Well, that's not going to work here. 7 is not going to have the same base as 3. So if I had, for instance, maybe had a 9, this would be more straightforward, where I could say that 3 to the x plus 2 is equal to 3 squared, and then just set the exponents equal to each other and know that x must have been 0. Okay, now this is what we can do in times of emergency where I have this guy. So there's two options here. The first option is I could go ahead and write this using my log rule, where I know that this would be log of the base, which is 3, and my argument is that answer on the other side is equal to my exponent. Okay, and so now at this point, I would need a calculator to evaluate log base 3 of 7. I don't know what that would be off the top of my head. So if I wanted to solve for x, all I would have to do is type that into my calculator and subtract 2, and that would get me my answer. Okay, the other thing that you could do, that's supposed to be a check mark, looks like a B. The other thing that you can do is take the log of both sides, because once I take a logarithm, I can get anything out of the exponent. So I could go ahead and take just the log of 3 to the x plus 2, and this is just log base 10, and I'm doing whatever I do to one side, I'm going to do to the other side. And so now I know if anything's up in the exponent, it actually belongs out in the front. So I would have x plus 2 times log of 3 equals to log of 7. And if you notice, it's going to turn into almost the same thing we just got, because if I divide both sides by log of 3, I would have x plus 2 equals to log of 7 over log of 3, which is basically just your change of base formula, where if you didn't have a regular calculator that could do a base in there, you could figure out the log of 7 divided by the log of 3. Then I go ahead and I subtract 2, and I would get the same thing. Okay, and again, I could have taken the natural log of both sides at that point because it's the same type of operation. We're basically just trying to figure out how would I be able to type this into my calculator. And that's what we're going to continue doing in 9.5. Today we're doing this where I would be okay with getting this answer. I don't need any sort of decimal approximation of this. Solving logs with a calculator, we're just going to be able to plug in those answers that we've been getting and get an actual answer out of them. That's all I've got for you for solving log equations.